Okay, we've been talking about multiplying fractions. Today we're going to start fraction division, okay, and that is part one. And so our objectives today is we want to be able to use visual models to divide unit fractions by whole numbers. We want to be able to apply and extend previous understandings of multiplication division to multiply and divide fractions. So for our warm-up here, we have some fraction of problems. So let's look at these three. And if you remember with fraction of problems, it simply means to multiply the fraction. So when I have a fraction of a fraction, I can just put a multiplication symbol over the of, and that reminds me to multiply straight across and multiply my numerators and my denominators. So the next one here, 1 times 1 is 1, 4 times 5 is 20. Next one, half of 1/4. And you could do the pictures as well as we've done with the area models, but the algorithm here of just multiplying straight across with the numerator and denominator is the quickest, probably most efficient way. But if you need that visually, you can do that as well. So here are some more problems that you can try on your own, so you could pause those and answer those now. Okay, we're going to talk about some vocabulary in regards to division. So I know we've heard these before, but the dividend is the number in division that is being divided. For example, in 35 divided by 5 equals 7, the dividend is 35. So you could think about in division, the dividend is the big amount that you're splitting up. And then you have the divisor, and in division, the divisor is the number that divides another number. For example, 35 divided by 5 equals 7. The divisor is 5. So the divisor is the number of groups that you're splitting it into. So if I had 10 people, that would be my dividend divided by 2 cookies. The cookies would be the divisor, the number of groups that I'm splitting things into. And then the quotient is the result of dividing one number by another number. For example, 35 divided by 5 equals 7. The quotient is 7. And so you have this diagram here. So if you're still not comfortable with those words, you want to make sure you are, because they'll show up on Evaluate or iLearn and in your book and moving forward in your math career as well. So you might want to pause and just study that. Make sure you have those down. Okay, so we're going to solve the following problems. You may use a drawing, a number line, or a fraction circle pieces to help you. So let's look at the first one there. A 6-meter rope is cut into 3 equal pieces. How long is each piece? So pause, go ahead and write your answer. Okay, so as I look through here, I have a 6-meter piece. It's being cut into 3 equal pieces. So equal pieces tells me that you're dividing, right? So I have 6, which is my dividend, 3 my divisor, and my quotient is 2. So each piece would be 2 meters long. Our next one here. A 1-meter rope is cut into 3 equal pieces. How long is each piece? So I have a 1-meter rope, and it's cut into 3, and I'm going to box equal pieces as well, because that tells me division. So how long is each piece? So I have 1 meter divided by 3. So take a minute, think about that. Is your answer going to be greater or less than 1? Okay, hopefully you've had a chance to answer that. I know that I'm taking 1 whole meter and dividing into 3 pieces, which simply gives me the fraction 1/3. It's going to be less than 1 whole on there. And I'm going to erase these now so that we have a little more work room on the next one here. And then the last one here says a 1/2 meter rope is cut into 3 equal pieces. How long is each piece? Okay, so I see I have a 1/2 meter. This time I don't have a whole number. It's actually a fraction. Same verbiage though. It's cut into and into equal pieces. So I know I'm dividing. So when I look at this, I'm dividing 1/2 by 3, which is what our lesson's all about today, is dividing fractions by a whole number. So go ahead and pause the video. Think about how you could solve that. Could you draw a picture? Do you know an algorithm already that you could do with that? Go ahead and pause the video and try. Okay, hopefully you've had a chance to try to divide 1/2 into 3 equal parts. So I'm going to draw a picture. And again, I know this doesn't look like a rope because it's a rectangle, but I'm going to split it in half, and I'm going to shade half of that in, because I know I'm only working with 1/2 of a meter. Now, it tells me here that I need to divide it by 3. So I'm going to take this half and I'm going to split it into 3 parts. So 1, 2, 3. Now, each individual part, and I want to actually split the other side into thirds as well, and each individual part is 1/6 when you count them up. So you can see I have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 pieces total. So 1 out of 6, or 1/6, would be your quotient. So when you divide a half by 3, each piece will be 1/6. Now I'm going to show you the algorithm that you could use for that, and we'll practice this today. Whenever I divide a fraction by a whole number, I can put the whole number over 1, and we have this fancy word we like to call the reciprocal. So you could flip over the second number, in this case the whole number, and multiply straight across, and you get 1/6. So we'll practice some of those things today. So how is problem 3 similar to problems 1 and 2? Well, we know they were both division problems, right? But they were different because we were dividing a whole number by a whole number. And then in problem 3, if you remember, that's when we were dividing a fraction by a whole number. So that changed things, right? So write a number model with a letter for the unknown for problem 3. So here's what that would look like. 1/2 divided by 3, and we don't know what the answer is. That's the unknown, so we put a variable or a letter. So when you get algebra, you put a letter in place of the answer until you find it. So let's look at the quotient, divisor, and each number model. So when I look at the 6 here and the 1 here, they're in the same position. And so I have to decide, is that the quotient? Well, I know the quotient is the answer to division, so that wouldn't be it. I know the dividend is the big amount that you're splitting up, the whole amount you started with. So that makes sense for the dividend. So those two would qualify for that. Now I look at the 3 and the 3 here. They're both in the same position, and I know that I'm splitting both dividends into groups of 3. So that would be the divisor. And then I know my answer to division is called the quotient. So how does the quotient compare to the dividend in each problem? So let me erase these marks so we can get a better look at this here. And so when you look here at it says the quotient, how does it compare to the dividend, to the numbers we started with? Well, if we look here, when I divided the whole number by 3, I got 2. So I can see here my dividend was greater than my quotient. When I look over here, same thing. I can see that my dividend is greater than my quotient. My quotient is less than what I started with, which is typical with division. Now, do you think the quotient for problem 3 will be less than the dividend? How do you know? So think about that for a minute. You're dividing by a half. You're taking a half and dividing it by 3. What do you think would happen there? Okay, so predicting the size of a quotient compared to the dividend is one way to judge the reasonableness of answers, right? So it's like making your estimate there, making sure it's not too crazy with that. So we're going to do some exploring with that to see if we can figure that out. So there's some solutions and strategies that you can use for a problem like this. You could use a number line to represent the length of the rope. You could mark the distance from 0 to a half as the original rope length. You could split the distance into 3 equal parts. And you can see the diagram below for an example there. And you could think, what would one of these pieces be called? Since 3 pieces fit between 0 and a half, 6 pieces would fit between 0 and 1. So one piece is a 1/6 meter. You could use fraction circle pieces to represent the length of the rope. If the red circle is 1, then the one pink piece is half. Think, how can I split half into 3 equal parts? Exchange the pink piece for 3 light blue pieces. What does a 1 light blue piece represent? Since 6 light blue pieces are equivalent to 1, we'll circle 1 light blue piece represents 1/6. So if you use fraction circle pieces, you could use that as a strategy. A lot of times you won't have those at home though. You could divide the rope into 3 equal parts, like finding 1/3 of it. So we're trying to find 1/3 of a half meter. 1/3 of 1/2 is the same thing as 1/3 times half, or 1/6. So does your answer make sense? How do you know? So let's see, we have 1/2 divided by 3. So another way to check your answer is by thinking about the relationship between multiplication and division. So like we said, we could write this as a multiplication problem. We could just rewrite it. So I always like to put the whole number over 1, and it's called the reciprocal. You simply just flip the second fraction and multiply straight across. And you get 1/6. And I know because I'm dividing and I'm splitting it into smaller groups that 1/6 is less than what my dividend of a half, which makes sense, right? When you divide things up, you're not getting larger groups, your product's getting smaller. Okay, so we solved problem 1 using 6 divided by 3 equals 2. But how can we use multiplication to check this answer? So think about that, man. How could I use multiplication on a basic problem like that to check? So a relationship between multiplication and division can also be used in problem 3. So let's go back up here and look. I could take my divisor and multiply it by my quotient to see if I get the dividend. 3 multiplied by 2 equals 6. Okay, so I can see that that's a fact family there, that it does indeed work. So one way that you can check your answer is to take your divisor and multiply it by your quotient and see if you end up with your dividend or your original. So if you want to check this problem, what would I multiply? Let's think about that a minute. I just said that if you take your divisor and your quotient and you multiply those, you should end up with your divisor. So will that work here? Let's see. And in this case, I would just say 3 over 1. And I would multiply it by 1/6. And I get 3/6, which is equal or equivalent to the 1/2 that we started with. So that shows me that my answer is correct. So the product we should get is 1/2 because that was our dividend, what we started with. So if I multiply 1/6 by 3 like we just did to confirm the answer, if needed, 3/6 and 1/2 are equivalent, just like we looked at. Okay, so what does this tell us? 1/6 multiplied by 3 equals a half. I can again use multiplication here to check. So I'm going to take my divisor and I'm going to multiply it by my quotient. So I'm going to say 3 over 1 for my whole number of 3. And I'm going to multiply it by 1/2. And I should end up with 1/6. But let's see. Ooh, that didn't work, did it? So what does that mean then? I did it wrong. You actually need to do, in this case, 1/3, and you want to multiply that by 1/2, and you'll find that it equals 1/6. Okay, and so in that case, you want to multiply straight across like that to check your answer. All right, and so you could have used your number line, fraction circle pieces, and relationship between multiplication and division to solve and check fraction division problems there. I can also draw a picture with a bar, something like that. So let's look at this problem here. So I want you to take a minute and read it. Okay, so it says 3 family members equally share 1/5 of a pan of cornbread. How much pan will each person get? So using cubes, I see there's 3 family members, so that's the number. 1/5 of, and it says equally share. So equally share tells me I'm going to be dividing. And then also I see how much will each person get. So each person get also is good words to help me understand that I'm dividing. Now I have to ask myself, am I dividing up 3 family members or am I dividing up the 1/5 pan of cornbread? Well, I know you can't really divide up family members. They're sharing the cornbread. So I would say for my number model, 1/5 divided by 3. And if you remember, we said we could do a couple different things here, but I'm going to multiply by flipping over the second number, or the divisor, and multiplying straight across. And I find that each family member should get 1/15 of the cornbread. Now, that seems reasonable because if we said they were going to get 3/5 or something like that, there's not even 3/5 there. There's only 1/5. So our answer is reasonable. Okay? And so we want to make sure that we're very careful with that. And if our answer is more than 1/5, our quotient, then we know somewhere we've made a mistake. But simply, you can take your divisor, put it over one, and then just flip it, or we call it the reciprocal, and multiply straight across. And that is how you do that. We can also do a picture here. So if I make it into fifths first, 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5. Not very even, but it works for what we're doing. And you're splitting it among 3 family members. You got to do it for each fifth. And I see that 1/5 here, and it's 1 out of 15 total pieces. And again, could do a better job drawing there, but you can see that 1 out of 15 pieces for each family member. So you're going to draw a picture to model and solve the problem. So like I said, draw a rectangle divided into 5 equal parts, shading one of the parts. And you can see that it looks a little bit neater than mine, right? So how can we use the picture to show how much each family member gets? Think about what we just did. So we know that there's 1/5 of a pan left. And then you could split that into thirds. And we can see in the drawing how much each family member will get, but we need to name it, right? So 1/15 by the time we split it up there and we draw in our lines. A little bit different picture than mine, but it still works. And so this is one way that you could do that if you don't want to use the algorithm. So you can see here that when they made all their lines there, they split the whole thing into thirds. We divided the whole thing into thirds, or divided by 3. We can see that each person was going to get 1/15. What number model summarizes the solution? And how can we check our answer? So we could multiply using the method of our choice and summarize results with multiplication number syntax. So we could simply multiply our divisor by our quotient to see if it equals our dividend. So let's look at this one. Jerome is making banana walnut bread. The recipe calls for 1/3 cup of walnuts. Jerome mixes the batter and pours it into 2 small bread tins. If he splits the walnuts equally between 2 tins, how many cups of walnuts will we have in each tin? Okay, and so I see splits, and I see equally between the 2. So that tells me I'm going to be dividing it up, right? Now I have to ask myself, am I dividing up those bread tins, or am I dividing up the cup of walnuts? Well, it says here if we split the walnuts, so I know that my walnuts is going to be my dividend. That's what I'm splitting up, and I'm dividing it into 2 different pans. Okay, so I want you to pause the video, see if you can figure that out using a number model or using an algorithm. Okay, let's look at this one together. So I have 1/3, and I want to divide it by 2 or split it in half. And so I know that 1/3 here, and dividing it into 2 pans. So if this was if the green here was 1/3, and then I'm shading in half of that, or dividing the shaded part into 2, I can see that I get 1/6. So each muffin tin will get 1/6 of cup walnuts. I could also do the algorithm. I want to put the whole number over 1, and then I multiply by the reciprocal, or I just simply flip it over, and I get 1/6 cups. So you could do the number model, or again, remember, you can put the whole number over 1 for the division problem, flip the second number, we call it the reciprocal, and multiply straight across, and the same thing as doing the division. All right, let's look at the next one here. There is 1/6 of a quiche in Cora's refrigerator. Cora agrees to share equally with her brother. What portion of the original quiche will Cora eat? So 1/6, I know that. And I see of, but see equally, right? And I also see share, which tells me I'm going to divide. And there, Cora agrees to share equally with her brother. I don't see, the only number word I see is 1/6. But I also see she's going to share with her brother. So if they're sharing, that means there's two people. Now I got to ask myself, what is my dividend? Well, I know that I'm dividing not the brother and the sister, but I'm dividing the quiche, right? Because it says what portion of the original quiche. So I'm going to say 1/6 divided by 2. And so I could draw a number model, but I want you to go ahead or write a number model and then draw a picture. But I want you to go ahead and pause the video. I want you to try to solve this one on your own. So 1/6 divided by 2. Okay, hopefully you've done your picture or you have done your number model and went through the algorithm there. But we have 1/6, so I'm going to split it into 6. So 1, 2, 3, 4, 5. And that gives me 6 lines. And it said 1/6, so I'm going to shade in 1/6 here. And I know there's 2 of them, so I'm going to split this whole thing in half. Now, they each get 1 piece, so that would be 1 for my numerator out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1/12. I could also do the algorithm to check that. So I'm doing 1/6 divided by 2. I'm going to write my whole number over 1. I'm going to rewrite this as a multiplication problem. So I'm going to flip the second fraction. We also call that the reciprocal, and I get 1/12. So using the algorithm and using the picture, I get the exact same quotient there. Now, you're going to go ahead and pause the video and turn to page 188, and we are going to look at a couple of those. So make sure I'm 188 there. Now, on 188, it says for problem 1 and 2, write a number model using a letter for the unknown. So for the letter of the unknown, remember use a letter as the variable. Solve showing your solution strategy, representations, or drawings. Summarize your work with the division number model. Check your answer using multiplication. Write a number sentence to show how you checked. 2 students equally shared 1/4 of a stick of clay. How much will each student get? So if we use cubes here, we can see 2 students, 1/4. Then I'm going to know my question. How much of the stick will each student get? Now, I see the words equally share, which tells me it's not multiplication, but it's actually division. So I want you to do your number model there. Are you dividing 2 students by 1/4 of a stick or of clay, or 1 for the stick of clay divided by 2 students? So think about that. So pause the video. Go ahead and fill in your blanks there. Okay. Hopefully you have those filled in. Let's check your answers to see how you did. So you would say 1/4 divided by 2 equals C. You could put whatever letter you want there. They put C to represent clay. So the letter is the unknown. And then the solution is where you give your actual answer. So they found after doing a picture and multiplication algorithm that they got 1/8 of clay. And then you can see the summary model. The summary model is just simply taking your number model and filling in the answer for the variable that you had up there, or the letter. And then you can check using multiplication. Okay, so you can see they took their product, multiplied it by 2, got 2/8, which is equivalent to 1/4. Number 2 here, it says 3 families equally share 1/3 of community garden space. How much of the community garden space does each family use? You have the same set of directions and expectations in this one, so I want you to pause the video and complete that now. Okay, so hopefully you've had a chance to solve that one so we can check your results. So I can see that they had 1/3 of the community garden space, and they were dividing it among 3 families, or equally sharing. They used G for garden space. You could use any letter you wanted there. And you can see their solution was 1/9 when they did the work. Okay, so you can see their illustration or their drawing to the side there. And then you can see their summary number model. Again, summary number model just simply means you're taking the number model and you're writing your answer in instead of the letter. And then they checked it using multiplication. So they took their solution and multiplied it by, or quotient, and multiplied by their divisor and got their answer of 3/9, or 1/3. So on 3 and 4, when you divide a fraction by a whole number greater than 1, is the quotient larger or smaller than the fraction? Explain. On these types, I like to give an example problem. So let's see, when you divide a fraction by a whole number greater than 1, so I might do something like 2/3 divided by 2 and put my answer. And then I would explain using the math and then my words, does that work? So giving an example where you're using a fraction and dividing it by a number greater than 1 will help you explain whether your answer or your question is larger or smaller. So give a number model to explain that. And then number 4, write a number story for 1/5 divided by 2. So think of 1/5 as something that you're going to share with 2 people or 2 groups or 2 containers. And then you have a home links that you can do for extra practice there.